Alright guys, as you can obviously see, I'm not here. We can't just wait until I get back to keep moving with material though, so we're going to do it through a video here real quick. I'll go as quickly as I can so I can get you guys as much homework time as possible. There isn't a lot going on today, so I think we can do it fairly quickly. If you need to take more time to take notes or to keep up, go ahead and just ask that they pause the video so that you guys have time to finish. I'm going to move pretty quickly to get you guys as much time as possible. A little bit of vocab to start out. A monomial is anything with just one term. Any expression with one term. Mono means one. Okay, nomial means name or term. So anything with one term, like 3 is a monomial. 4x to the 12th is a monomial. Negative 9w cubed y to the 7th x to the 101st is a monomial. There's only one term there. Okay. A binomial, bi means two. Think bicycle or bifocals, 2 wheels, 2 lenses, anything with 2 terms. So 3x minus 4, 12w to the 5th minus, let's go plus 7x to the 12th. It's going to be a binomial. 2 terms separated by a plus. Okay, a trinomial is anything with 3 terms. Think tricycle. It's going to have 3 wheels. I think they make trifocals too, 3 lenses. 3x to the 7th plus 4w minus 9 is a trinomial. It's something that's got 3 terms. Okay, a polynomial. The official definition of a polynomial is the sum of monomials. So if I were to add a bunch of monomials together, like this is a sum of 3 monomials, making a trinomial. Each one of those is a monomial, right? Each one of those is one term. A polynomial is something with many terms. Okay, poly means many. The official mathematical definition of a polynomial is a monomial or the sum of monomials. So a monomial would actually still be a polynomial. Okay, a polynomial has many different parts. We talked about the terms. Each one of these things is a single term. So this has 4 terms. We always write polynomials in decreasing powers of x, or whatever your variable turns out to be. It doesn't have to be x. Because if you look at this one, you'll see that it is written in decreasing powers. The highest power of x, x cubed, comes first. Then the next lowest, which is x squared. This one doesn't have an exponent, which means it's an exponent of 1. That comes next. This one doesn't even, the last one doesn't even have an x. You could say that there's an x to the 0 there, because x to the 0 equals 1. Anything raised to the 0 is a 1. So that's written in decreasing powers of x. The leading coefficient of a polynomial is the number multiplied by the first term. So in this case, the leading coefficient would be a 2. The degree of a polynomial is the highest power in that polynomial. Okay? And the constant term is something that doesn't have a variable. It's a constant number. 12 is always 12 no matter what. Okay, just some vocab that we're going to keep using as we get through this chapter. Here's a polynomial. It's all scrambled up. We always want to write in decreasing powers of x. So this is the highest power, x cubed. We have an x to the first and an x to the 0, if you want to think of them that way. So negative x cubed comes first. That negative is attached to the x cubed. Plus 15x. X to the first is the next highest power. And then we're going to add our plus 3. Okay. The leading coefficient of this polynomial is a negative 1, right? There's a negative 1 right there. The degree is the highest power, in this case, a 3. So it has a third degree, or a degree of 3. And this is a trinomial, 3 terms. Go ahead and take a second if you need to. You can pause it if you're not all done. Like I said, this stuff is all in section 9.1 in your book also. Here's a table with 5 different expressions in it, and we're going to answer some questions about them just to make sure we're familiar with the different terminology involved with polynomials. We're going to be using it a lot, and we need to be comfortable with it. So 9, is it a polynomial? Well, the definition of polynomial was a monomial or the sum of monomials. So that is a monomial, so yes, it's a polynomial. Okay, classify it by its degree and number of terms. Well, it has a degree of 0, because there are no variables in there. Number of terms would make it a monomial. The second one has, well, first of all, is it a polynomial? Yes, of course it is. It is the sum of monomials. It has a degree of 2, the highest power. And it is a trinomial. It has 3 terms. This one's a polynomial also. It is the sum. In this case, it's the difference. But if I think of this as a negative monomial, I'm adding it. And the point is, I can add or subtract monomials to make a polynomial. So yes, it's a polynomial. The degree? It's hard to say. If this n is a small number, then 4 would be the highest power. Okay, so we don't know, so we're going to say that it is a polynomial of the nth degree, meaning the degree is n. I don't know what n is, but for now we're going to call it an nth degree, or a degree of n. It has 2 terms, making it a binomial. Lastly, this one is also a polynomial. The highest power. Now that's kind of tough. That one doesn't have an x variable. But if it did, it would be x to the 0, which is actually higher than -2, right? This actually would be an n to the 0. 0 is greater than -2, so this has a degree of 0. And it's a binomial, 2 terms. This is a polynomial. Now this is interesting. There's 2 different variables here that have powers. It's kind of your choice which you want to go by. Most often, we will classify based on the power that is the highest. Okay. So we're going to say that this is a binomial, 2 terms. To the 4th degree. Now I need to backtrack a little bit. We said that these 2 were polynomials. No, that's actually wrong. I did not mention another caveat or an exception to what a polynomial is. This has a variable exponent. You can't have variable exponents. Okay. This one has a negative exponent. You can't have negative exponents either. Okay. We're going to talk more about that as we keep going here. You can't have variable exponents and you can't have negative exponents. So we're going to say that those are not polynomials, which would make the rest of that irrelevant. Okay. However, those other 3 are, the first 2 and the last one. Okay. Moving on. We can add and subtract polynomials. There's 2 ways to do that. Really, they're the same way. It's just 2 different formats for adding them. We can use what they call the horizontal method or the vertical method. We'll show you both for 2 different problems here. If we're using the horizontal method, we're going to leave them written horizontally like this. Horizontal meaning across. And I'm just going to make sure that I add up like terms. This is a 2x to the cubed, or 2x cubed, 2x to the 3rd. That can only be added to other x cubes. I've got one right there. So I have 2x cubed plus 1x cubed gives me 3x cubed. Those are done. Change colors. I have x squareds next. So I look for any other x squareds. Here's one. I have a negative 5x squared plus 2x squared. It's going to leave me with a negative 3x squared. And those are gone. Change colors again so we can see what's going on. The last term is just an x. So I look for any other x's. And I don't have any. I don't have any other powers or any other terms with a power of 1. So I'm just going to keep that as an x. And that guy's done. And then anything else that's left over, there's a constant term of a -1. Okay? That is how you add polynomials. It's just combining like terms. We've been doing it all year. We just haven't been calling it this. The vertical method makes more sense to me. That's what I use most of the time. And we're just going to line it up vertically, one on top of the other. So I'm going to copy the first one down. 3x squared plus x minus 6. Making sure that it's written in decreasing powers of x. The second one I'm going to write down beneath it. I have to make sure that it is also written in decreasing powers of x and that the common powers of x line up with each other. So I wrote the x squareds first. This x squared is going to come next. Then I go to the 4x, line it up under the other x to the first term, and then the constant term last. And then we're just going to add them up and down. It really doesn't matter to me which one of these you use. It's totally a personal preference, whatever's easiest. Negative 6 plus 10 is 4. X, that's plus 4x is 5x. 3x squared plus x squared makes 4x squared. Those are both positive numbers. And we're done. Okay, adding polynomials, or even subtracting polynomials, which, spoiler alert, is coming next, all it means is combine your like terms. Okay, if you're not done, go ahead and pause it to finish taking notes, otherwise I'm going to move on. Find the difference just means subtract. Okay. Now, I want to caution you, it is very, very easy to miss double negatives when you're doing subtraction of polynomials. So you have to be very careful. If we want to go horizontal method, that works. 4n squared. So I look for other n squareds. There's one right there. So I have 4n squared minus a negative 2n squared. 4n squared minus negative 2n squared. So that's plus. So I have 6n squared. Those are done. Then I jump to a 5. I have 5 minus negative 4. 5 minus negative 4. So that's plus also. So that's a positive 9. And those are done. I should have been changing colors for you. The last one, all that's left, is a 2n. But I have to remember, there's a minus 2n. So I have 0n out here, because there were no terms that are just n's. 0n minus 2n. So I have 0 minus 2n is a negative 2n. We always want to write it in decreasing powers of x, or in n in this case. 6n squared minus 2n plus 9. Okay, you can use the vertical method if you want to as well. I would copy down the first one, 4x squared minus 3x plus 5. I'm going to put a minus out here, and I'm going to write the second one in parentheses. I think that helps keep track of the double negatives when they happen. 3x squared minus x minus 8. Those line up pretty nicely. We just subtract straight down. Again, be very, very careful for double negatives. Watch out for them. 4x squared minus 3x squared leaves me 1x squared. Negative 3x minus negative x. Negative 3x minus negative x means I have a double negative. I'm going to add. Negative 3x plus x would be negative 2x. We're just combining like terms. No reason not to use a calculator if all the negatives try to confuse you. Do that if that's what you need. And then my constant terms. 5 minus negative 8. Again, a double negative. 5 minus negative 8 means 5 plus 8. Positive 13. Just like addition, you can use either the horizontal or the vertical layout, whatever seems to work best for you. I really, really, really cannot stress enough that this needs to be done very slowly, carefully. I like to draw these arcs if I'm doing the horizontal method. I think that really helps me keep track of what's going on. If I'm doing the vertical method, I write this negative out front when it's subtraction, and I put the second polynomial in parentheses, just to help make sure that I'm keeping track of everything. I don't miss anything. All right, that's pretty much it, guys. I know I didn't do a ton of examples. Section 9.1 in the book has a lot more if you want to look through that. The learning targets on my website have Khan Academy videos for this too. If this really wasn't enough, it's really hard to teach this to you through a video. I know that I can't answer questions. I can't clarify things. So do your best, help each other. If you're still confused, go ahead and look in the book. Go ahead and get on Khan Academy through my website and check out in the section 9.1, adding or subtracting polynomials. Hopefully you guys are okay with it. It's just combining like terms is all it is. Okay. Homework is day 1. You're about to get a homework sheet and a worksheet for day 1. You're going to turn the worksheet in tomorrow, so make sure you have your name on it. Maybe do that first and bring it with you tomorrow. Good luck.